Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of roboticsandautomationnews.com. In this interview, I speak to David Lakatos, Chief Product Officer at Formlabs, one of the world's leading manufacturers of 3D printers. The portion of the interview in which I speak to Stefan Hollander has been trimmed for length and will likely feature in a future video.
Well, thank you very much for joining us. I'm David. I'm the Chief Product Officer at Formlabs, and we also have Stefan in the room.
Hi, Stefan Hollander. Here just joined 2 months ago. Still pretty fresh, so I'm most likely not the one who can answer every question about the product in the detail, but I'm having a bit of a background in that area, so I'm happy to help and run through this one.
Okay, hi Stefan, hi David.
Very nice meeting you.
Very nice meeting you.
Good to meet you.
I've gotten a little bit familiar with your publication, and let me ask two very short questions. One of them is, how much time do we have, just so I can make sure that we don't run over?
Well, normally it's 20, 30 minutes. We'll try and keep it to 20. I'm not sure how many questions I can think of, but it's an interesting company, so I'm sure I'll think of... I usually ask too many questions, but let's try for about 20. Is that okay?
Absolutely. We have as much time as you have. Second of all, how familiar are you with Formlabs? I just don't want to repeat things that you already know.
I don't know that much. I know that it's a 3D printing equipment supplier, but beyond that, I don't really know a lot.
Okay, no worries. I can start from the beginning. So I'm going to run through our history a little bit. So we started out of Boston, out of the MIT Media Lab. Actually, that's where I went to school as well. The original goal of the company was to figure out how we can kind of fill this problem that there is industrial and professional equipment for 3D printing additive manufacturing, but it's super duper expensive, hundreds of thousands of dollars or even millions of dollars. And on the other side, there are consumer printers for $499, but they're not really, if you're an engineer at BMW, you're not going to be interested in buying one. So our goal was to create an accessible, easy-to-use platform for 3D printing. And we went to the market in 2012 with the Form 1 on Kickstarter. We raised about more than $2 million, sold a couple thousand printers, which was, we were very ambitious, but it kind of surpassed our wildest dreams, and went on over the next roughly 7 years to build a company that is today a global company of 550 people. We have over $100 million in revenue, and have kind of went through the Form 1, a Form 1 Plus, which is a kind of updated version of the Form 1, the Form 2, and what we're announcing today, and I'm super excited to talk to you about this, is the Form 3 and the companion printer called the Form 3L, which is the larger version of the machine. So I don't know if you're joined over the video, but if you are, you can. It's kind of right next to us, which is the Form 3. If not, we can send you the recording later.
Yeah, I can see the video, and I would like the recording afterwards, because I normally edit it slightly and upload it to our YouTube channel. But I can definitely see it.
Great. Yeah. So basically, what we're announcing today is this is the Form 3, which is actually the 4th generation version of our SLA product line. SLA stands for stereolithography, which is basically a way to turn a liquid into a solid. It's a very precise. It's actually one of the most precise and highest qualities, highest surface finish versions of 3D printing, and it's very versatile. The reason for that is we're able to formulate actually all of our materials down to the molecular level. We have now close to 150 engineers, and of them, 30 of them are actually material scientists. And their job is to formulate different versions of our plastics, which comes in the flavors of very rigid material or flexible materials, things that you can use for rapid prototyping, enclosures or grips or overmolds. We also have materials that are biocompatible for dentists. This is something that we have explored over the course of the last 2-3 years in depth. We were able to have a very, very large kind of foray into the dental industry. We are by far the most installed both desktop 3D printer, but also the most installed dental 3D printer. So we have biocompatible materials, which you can make surgical guide templates. You can make full dentures. You can make models that you can then form clear aligners over. So it's a super versatile platform that can be used kind of equally well by engineers, product designers, manufacturing engineers, dentists. We have lots of jewelry customers who are making investment casts with our materials that they can then burn out and invest in with precious metal, make an investment cast out of. So it's a platform. What we are launching today is kind of the newest generation, as I said. It's called the Form 3 and the Form 3L. If you're not familiar with our product, again, it's kind of an advanced version of our SLA platform. We call it LFS, which stands for Low Force Stereolithography. The kind of new version of the printer enables even more reliable and higher quality prints. We achieve that by lowering the peel forces on the parts. This is a fairly technical term, but if you kind of compare the iterations between our products and generally in stereolithography, one of the defining kind of sources of errors and inconsistencies is how you transition from layer to layer within a print. And so with every single iteration, we reinvented the process. We went in the Form 1, it was a kind of tilt mechanism. In the Form 2, it was a slide peel mechanism. And here, it's a kind of a flexible tank and linear illumination engine, which allows much smaller forces to be acting on the parts, which reduces errors, increases reliability, and really enables super high quality parts. So again, it's kind of drilling at that. How can you deliver for every engineer and product designer a 3D printer that they can put on their desk and materialize their designs as quickly as possible? Maybe one more thing before I want to make sure that it's not just me talking, but you can ask questions. But one thing that is very important to our product is the accessibility, which is kind of driven by how we design it, how easy it is to use. It's not, you can literally unbox it the same way as you would unbox a laptop or a consumer electronics. You can take it out of packaging, set it up within 5 minutes, and start your first print immediately. And the second part of accessibility is that it's a very affordable 3D printer. Our price point is $3,500, which is unheard of when it comes to professional 3D printers. And we think that that's the reason why today we are the most installed 3D printer, and also the reason why it was so easy for us to expand all over the globe. Actually, I'm calling with Stefan from our office in Berlin, where our European headquarters now has over 100 people, and we have offices across North America. We have 2 offices in Boston and North Carolina. We have an office here in Berlin, 1 in Budapest, and we have 3 offices in Asia as well. So it's very truly a global operation at this point. Right, I'll take a quick pause there and see if you have any questions here.
I do, but if you want to finish any other, I suppose I could ask questions. Would you prefer me to ask questions now, or would you want me to wait until the end?
No, go for it.
Okay. What do you think? I know you mentioned and sort of elaborated on the dental sector as being a very good market for you, but you also said that your company has grown really fast, maybe surprised yourself. But so I wanted to, more details about what the main reasons are for your growth in terms of the types of markets that have been interested. Because I always think of engineering companies, automotive companies, the kind of companies that they would need prototyping equipment like this. But what has been, you think, the main reason or reasons for your fast growth?
Sure. So I think the history of 3D printing is pretty fascinating. It kind of uncovers. I'll get to your questions, but I think it's good to look at it in context. So 3D printing in general has been around since the mid-'80s, and for a good 10, 15 years, it was exactly the market that you would expect and that you mentioned as well. Rapid prototyping, product designers like the largest ones, Apple and GE, all of the ones that you would expect to be able to afford a cutting edge technology that was not yet very polished, and it still had a lot of issues, being able to invest millions of dollars in order to kind of be on the cutting edge and able to prototype with 3D printing. Only in the kind of end of the 2000s was when there are a couple of things that happened. One, a lot of the patents started expiring from a lot of these core 3D printing patents. Stereolithography was actually the first one in 1984 when they invented it, and it kind of expired in the end of the 2000s. And then in quick succession, almost all of them, all of the core patents expired. And there was this huge explosion of 3D printers. That's when you might have heard of MakerBot or a couple other companies that were dominating kind of like the news articles of like the early 2010s. This kind of Cambrian explosion of technology gave away to a lot of kind of new type of ways of using the machine, and obviously a much more kind of a democratization of something that was very expensive before. But what was also kind of the problem, that was kind of the fallout of kind of in the middle of this decade in 2015 or so. A lot of these companies actually failed to deliver on what they promised their customers. And because it is fundamentally hard to build a 3D printer. So in a very short version, the reason why we are successful because we are both able to deliver on the promises that a $3,500 printer that can really get all of the designs at a 25 micron layer height with 140 micron spot size, able to kind of create the precision of models that these engineering product design customers want. And at the same time, we were able to innovate on all of the materials that then enabled us to go into adjacent applications. So this is where the core of it is really this engineering, product design, and rapid prototyping use case. That's the biggest one still. But where we have seen a lot of very exciting kind of like foray into new ways of using it is what we call rapid manufacturing or mass customization, where customers are using 3D printers not to create successive prototypes to achieve a design and to test it out, but to actually deliver a part to their end customer. So dentistry is a great example for that. There you're making custom parts for every single one of your patients. And it's not a generic design. You're not trying to test out anything. You're there. The dentist goes into their office because they want to give a surgical guide template that then will be able to help the implantology process, or a clear aligner that will help with orthodontic use cases, or a tray material that will help with the process of creating all sorts of dental equipment for those dentists. Similarly, in audiology, where you're able to make custom hearing aids or earplugs or various other things that really is benefiting from the customization because it will perfectly fit into your ear. And if you kind of play out that timeline, that we think that there is going to be a lot of different use cases that will benefit from customization. So we're already working with companies like New Balance, for example, working on custom shoes. But we're also working, an interesting use case was something that we announced last year, which is a customized razor handle with Gillette. And there it's less about customizing it for the user's kind of physique or body, but it's more about personalization. So kind of involving the customer in the creation of a new object. So these are all kind of belonging to this rapid manufacturing and mass customization umbrella that I think is going to really give 3D printing kind of to be able to go one step further away from just the core rapid prototyping use cases.
Thanks for that answer. Very informative and wide-ranging, and it gives me a lead into this whole trend towards setting up mass. Well, I don't know whether it's called mass manufacturing or mass customization. This idea that companies like yours, 3D printing companies, can provide a manufacturing on a mass scale. Obviously, it can be customized and suited to individual customers and things like that. But how does what am I trying to ask? What I'm trying to say is that it seems these kind of machines are suited to individualized, customized manufacturing, but I can't see them mass manufacturing in a cost-effective way, competing with traditional injection molding and other sort of techniques in traditional manufacturing. What's your view on that?
Yeah, I would never say that it will replace injection molding. I think there are some people that try to claim something like that in 3D printing, but I always try to be not more conservative, but more realistic. I think there is a way more exciting kind of part of 3D printing in it. I think if 3D printing would want to, 3D printing is not good at making the same part necessarily exactly over and over again at millions and millions of parts. I don't think we're going to be manufacturing basic parts of a consumer electronics phone with 3D printing. That's not where its strengths are. The same way when you have a tool shop, you're not going to use a hammer necessarily to split apart a piece of wood, although you probably could, but it's just not a very efficient way of doing it. So 3D printing really shines when there is customization or a hard to fabricate part comes in. So let's take an example, dentistry. I think that's one of the clear examples here. There are clear aligner companies that are making literally millions, tens of millions of parts every year with 3D printing. So the scale is definitely there. But the reason that they're using 3D printing because every single one of those models is different. And so I think once there is a demand for it, 3D printing can deliver. Our version of this is called the Formcell. So we have a product that is employing automation with 8 printers and a kind of post-processing solution, all with automated by a robotic gantry. That I think we have a video of that we can send you right after this, and it's on our website if you want to kind of check it out while we talk. But the idea is to be able to automate the today manual process of 3D printing. We think that the main part to automate is really the labor portion. So that's manufacturing is all about cost per part. If we would be able to achieve a cost per part at 100 million quantity that beats injection molding, people would be using 3D printing instead of injection molding. But we don't think that at 100 million quantity, we would be able to do a good job. But at a quantity of 1, if you would try to use injection molding to make those dental clear aligner models, you would achieve an incredibly expensive cost per part because you would have to make a new tool for every single model. So Formcell is really a way to kind of automate the arduous process of the labor. We are automating loading printers, moving printers from stage to stage, from the printing part to the washing and curing part, which are kind of integral parts of the process, and then delivering it on kind of a dolly that then can be pushed into the next phase of manufacturing. And we already have dental customers that are actually who own multiple of these Formcell machines that are able to automate their process of creating unique parts for their patients. And I think that's a very interesting part. That's what's going to enable, if Gillette wants to continue the experiment and roll it out worldwide in a very large way, they would be using something like the Formcell to get there.
And actually, if I just may add there, I think the whole Gillette project as such is the best example because, of course, both technologies will live along. So what you see here is the handle, which can be very different. I mean, just a couple of examples. But of course, those would be connected then to a very standardized piece of the product itself, which is then connecting to the blade itself, right? So in the end, there will be not like a direct replacement, but I'm pretty sure that the combination out of both technologies will be creating a lot of unique and new opportunities that will be then helping the customer to, have a personalized but still cost-efficient tool in his hand. And therefore, it will just live together and create new markets. That's what I believe.
Yeah, it's very interesting to me that companies that I've been following and covering, mass manufacturing companies, traditionally make very large quantities of the same item, whether it's automotive companies or other types of companies. They're very interested in the idea of, I can't remember the phrase, unit of one or something, the mass customization thing. I don't know why they're so interested in it, because they're traditionally making very large quantities of the same thing. Maybe it's the individualized, customized, components in the dashboards or I don't know. I can't think of that many examples where traditionally mass manufacturing companies would be. I don't know why they're interested in 3D printing to that extent. I can understand dentistry and medicine in general. You can, prosthetic limbs and hearing aids, as you said, and obviously teeth. It all sounds very sensible. But why do you think the mass manufacturers, the companies that have very big businesses, on the basis of making the same thing, tens of thousands or even millions of times, why do you think they're interested in it? What's been your experience, possibly?
Yeah, I can tell you my version of the story, which is that, again, I am skeptical that we're going to suddenly replace every single 3D printer with an injection molder. I think that's not realistic. But at the same time, I do see a customer need emerging where people want, same-day shipping, customized, products, made locally type of movement. So I think when a mass manufacturer of any device is thinking about how to employ 3D printing, a lot of it is reimagining their supply chain, reimagining the way they make things. So, I always think about Amazon in a lot of ways. There are so many, a local warehouse, like where I live in Boston, and there is a large Amazon warehouse in Framingham, which is 20 kilometers from Boston. That's where they distribute almost 90% of the things, because they know roughly what people are going to order. If they would have 5 years, 10 years from now, a park of our machines, and they would be creating products for the customers when the need arises for that person, for a personalized product, I think people will be able to afford, like they would pay more for such a product. And so I do think that there is a change the way that we make things in general. Again, I'm not in the camp that will think that everything will be replaced by 3D printers, but I think that there are a ton of things that would benefit from 3D printing. Mass customization, high value, highly customized stuff is just the tip of the iceberg. The dentistry, audiology, medicine, prosthetics, these are very custom and very expensive things. But if I think about sunglasses, for example, if I think about jewelry, if I think about garments, there's a bunch of things that could be made with 3D printers, could be more customized, and could deliver more value to the customers, and would enable local manufacturing closer to the end customer. That would ultimately ease on supply chain, would be able to deliver. The designer would be able to design until the last moment before, today, a fashion, like this is some of the conversation we have with some apparel companies in general, that their supply chain is very long. And by the time they design their spring collection, they need to commit to that design a year before. And, Instagram keeps on rolling for an entire year. And by the time they get to shipping a new shoe or a new sunglass or whatever, the market has changed and nobody's able to follow it. So if you would be a sunglass manufacturer that would be able to follow it and would be able to get to the market and close the designs a month before they go to the shops, you would be able to have a huge edge. So I think that there is a movement that will push kind of the envelope on how people are rethinking manufacturing. But again, will Apple change the way they make iPhones? 100 million of them, 9 months ahead. I'm skeptical of that, but maybe, I don't see 20 years into the future. Maybe that will come as well.
Right. This is what I mean. A lot of the comments that I've been reading, or stories I've been reading, I have been mass manufacturing companies talking about 3D printing. And they're obviously, I'm sure they're investing quite heavily in the technology. And beyond prototyping and customization, I don't know what else they'd use it for, but that in itself is obviously a very big market, both for companies like yours as as well as them. You know, they get rapid prototyping and so on. But I think
a lot of automotive companies, I think, where you see these investments, I think there are two main threads, just so you understand it better. I think you probably heard about these as well, but one of them is spare parts. Again, it goes back to the supply chain argument that a car, after it's being manufactured and the lines are closed, they try to make an educated guess on how many spare parts they will need for the entire fleet of that car model, or you can replace car model with any other type of equipment. And that usually is a very sketchy calculations because it needs to understand failure rates over time and amortization, all of that stuff. So they usually end up either overproducing, which means that they will have to write off inventory, or they will underproduce, which is even worse because they will need to restart a production line that was already scrapped once. So spare part manufacturing for 3D printing is great because you don't have to reinvest in the tools. You don't need to reset up a manufacturing line. You can use 3D printing and maybe at a little bit higher cost produce those parts that then will go into equipment. So I think that's a very clear path. The other one is personalization, and I think you mentioned the dashboard example. I do think that there are tons of, like, everything that we touch, if it would be customized for you, it would be better to use it. A very good example, I think, for this is power tools, especially in manufacturing lines. Every power tool that they use to fasten screws and whatever it is, the handle gets used by a worker for many hours a day. It is a generic handle. It's not customized for that particular worker, and you will get more fatigued if you have a handle that is too big for you or too small. So there are tons of little touches that you can add to everyday objects and your car that will benefit from this customization. And I think, again, these are all very interesting industries and applications themselves. And as you kind of like add them up, it becomes a very interesting opportunity.
Yeah, it is very interesting. I knew that instinctively, but your insight is very helpful. I didn't think about the spare parts and the way they plan for them to, to supply them. I think it makes sense for them to use or at least consider 3D printing as a way to go in that school. That totally makes sense. Appreciate that insight. I wanted to ask about materials. One of the things I've learned is that the 3D printing isn't able to handle steel and some of the other things. Apparently, that's the developments have got to a point where steel is part of the list of things that you can deal with. But I was wondering what your overview or maybe insight into kind of materials that are required by the market, but maybe 3D printing hasn't quite got there yet, or what things are being developed. I mean, I read a story today about some 3D printing process developed in some university where it can, I can't remember the word used for capillaries or something, capillaries, the blood cells or blood, very, very tiny, minute things in human bodies. Mm-hmm. And obviously internal body parts, whether larger organs, all these kind of things that sound macabre, but it seems to make sense that 3D printing might have a contribution to make in these areas where, beyond prosthetics, maybe even replacing people's body parts, internal organs and things like that. What's give us an overview of materials and what potential there is for 3D printing to help.
Sure. So the largest part if you look at 3D printing top down, the largest part of materials is plastics still. Like our printer, our printer, we have 20 different materials, all formulated in-house and manufactured by us, that are achieving kind of different moduli, different elongation. They kind of range from very hard to polypropylene-like to ABS-like to silicone-like rubbers and all sorts of things in between. So it's kind of a good chunk of the plastics that you would see in injection molding or thermoplastics in general. We also have a ceramic material that I'm really proud of. It's also a filled plastic that if once you sinter it, the plastic burns out and you get a dense ceramic part. And there are other kind of ways of kind of getting to kind of exotic materials that we're still working on. Kind of zooming back top down, another portion is metals, as you said. Metals, well, I have two comments generically. One is that metal 3D printing has been also around for a while. They're notoriously expensive machines and very hard to operate. So the number of metal 3D printing machines out there is actually very, very small. And they can print from steel, they can print from actually fairly exotic titanium and other type of materials. There is a process called DMLS, which is direct metal laser sintering, and it can produce amazing parts. I love watching those machines, but we are talking about millions of dollars invested. So the number of companies that have the need and can invest that amount of capital for it is a fairly small group. Bioprinting, the other thing that you have mentioned is, for me, in the kind of exotic uses of 3D printing, I would say it is definitely a research project at this point. There aren't organ printers kind of available for purchase. I mean, of course, as a person who is aging, like all of us, is definitely an interesting part of 3D printing. It's something that I hope we'll figure out as an industry over the course of the next couple of decades. But it is fairly exotic at this point, and for me, it belongs to kind of this promise of there are a couple of promises in the 3D printing world swirling around, like food 3D printing, organ 3D printing, everybody having a 3D printer at home and downloading things from Amazon and printing it out for themselves. All of them have a nugget of truth behind them and something that is driving this stream. I think they're very appealing in general, but they are exotic and not mainstream today.
Yeah, but it's so interesting to talk about, and especially because I do feel that there's a very strong driving force or a very strong urge in science, if not industry, to try and 3D print humans like they do in Westworld or something like that. And I can understand it. On the one level, they could justify it on the basis of health reasons, helping people to regain, I don't know, use of limbs and whatever. But I just think I don't want to say sinister. It's just that human nature to want to achieve or do something that is that amazing, to be able to 3D print an entire human being. And I don't think it's that far away. I don't know what your opinion is. I know you said 2 decades, 10, 20 years, but yeah, that doesn't seem like a long time, If in 20 years you could 3D print an entire human being like they do in Westworld, that's quite a scary thought in a way.
I mean, humans like to play God. Yes, that's very, very, very common. I think that's why we're flying, right? So no, I mean, I agree 100%. As an aging human, I'm very interested in the printers that can print various organs as they expire. I would say that today, as far as I know, and I'm certainly not the biggest expert on organ 3D printing, but there have been definitely parts of an organ have been printed successfully, and as how much this is printing versus synthesis is another one. 3D printing is a generic term. A lot of times this is like cells building organs themselves. It's more synthesis than printing. But it is like it's a growing cells.
Okay,
less than printing, but certainly I'm fully with you that it's very exciting.
Well, it doesn't sound like some part of your business plan anyway. The reason, I mean, you could argue that because you're doing teeth, what's the material that you're using for teeth anyway? Is it enamel or what is it that if you do print dentures or whatever, what is it? What's the material that you use?
It's a photopolymer acrylite methacrylite. So it is a plastic. It's not a filled plastic today. It's not a ceramic and it's not enamel or anything like that, but it is strong enough. The dentures today, most of the 3D printed dentures are actually for to be used kind of on a temporary basis. So in between, when somebody gets a denture, it's usually a very, very arduous and long process. And for the duration of that process, which can be many months, 6 months, the patient doesn't have a denture in between. So it's a horrible feeling, and it's not pleasant, both from an aesthetic perspective for the patient, and also not great because they're not able to eat a bunch of most foods actually. So it can be actually dangerous as well. So our dentures are used on a semi-permanent basis as well, but a lot of times for kind of temporary kind of to make sure that while the final denture gets manufactured, they're able to use it. So while it's a plastic, it is actually able to function as a kind of a fully semi-permanent denture, which is just quite amazing for a patient that otherwise wouldn't be able to get a denture for many months.
Right. Okay. Well, finally, I think as usual, I've been asking too many questions, but finally, I should ask you for some numbers. I don't know if you make numbers public, but I know you said you've raised a certain amount of investment. But what are the other numbers in terms of how many units sold, or any other things that you can share in terms of income and revenue, or anything that you can sort of give us to give us a picture of your company?
Absolutely. So we have 550 employees, I believe 7 offices. Somebody should yell at me if I'm not saying that.
No, that's totally correct.
And we made it public last year that we closed the year basically like we are at well above $100 million in run rate. As far as our revenue goes, we've shipped more than 50,000 printers, and we have made more than 40 million parts on our printers.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.